Need help from a math god.
Did somebody call me?
Hey,
What's up?
I need your help.
With?
Well, I know that you are the math god, and I have a test coming up, and I need your help with it.
Absolutely. What's the test on?
It's on binomial distributions.
I got you. Go get some notebook paper.
A few moments later.
Okay, I got it!
Okay, so with the binomial probability distribution, you have two possible outcomes, success or failure, with a fixed number of trials.
Okay.
A binomial experiment is a probability experiment that satisfies the following conditions. 1, the experiment is repeated for a fixed number of trials, where each trial is independent of the other trials. 2, there are only two possible outcomes of interest for each trial, can be classified as a success or as a failure. The probability of a success, P, is the same for each trial. 4, the random variable x counts for the number of successful trials. The notation for binomial experiments is n for the number of times a trial is repeated, p for the probability of success in a single trial, and x is the random variable that represents a count of the number of successes in n trials.
So can you show me an example?
Yeah, absolutely. And I will incorporate calculator use into it as well. So, here's our example problem. Savings. 55% of U.S. households say they would feel secure if they had $50,000 in savings. You randomly select 8 households and ask them if they would feel secure if they had $50,000 in savings. Find the probability that the number they say they would feel secure is A, exactly 5, B, more than 5, and C, at most 5. So, to start this problem, first we would need to establish the n and the p. The n is 8 and the p is 0.55. Now let's start with letter A. We would word this like this. P parentheses 5 equals a binomial PDF, and then we put 8.55 and 5. And now, here's when we plug it into our handy dandy calculator. And then you go second distribution, and you go down to binomial PDF, and then you plug these numbers in. 8.55, 5. And you get your answer, which is 0.2568. For part B, we will do 1 minus binomial CDF, parentheses 8.55 and 5. And then we plug that in on our handy dandy calculator. Once again, we put 1 minus second distribution, but we go to binomial CDF, and then we plug in these numbers, 8.55 and 5. And you get 0.2201. Okay, and for the final section of this sample problem is section C. You would set this up using binomial CDF. And then put parentheses 8.55 and 5 again. And then you plug that in your handy dandy calculator once again. And you get 0.775 999. And you have completed the problem.
Thanks, math genius, the goat himself.
Woo!